Okay, today we're going to add and subtract radicals. By the way, do we like subtraction?
Not as much as addition.
So yeah, so we could always change. Subtraction is really adding the opposites. So we could just say adding radicals, adding radicals. So today, if you pay attention on this, if you understand how to do this simple, if you know how to simplify this simple expression, 2x plus 3x plus 6y, if you know how to do this, then you could do the rest of it. Okay, you could actually add and subtract radicals if you know how to do this. Turns out, is this pretty straightforward? 2x plus 3x plus 6y. Do you all know how to add or simplify this?
Yeah.
Go ahead, everybody do it. I'll wait. Because if you know how to do this, you know how to add and subtract radicals. Go ahead, everybody try. I'll wait. Who has the answer? How about Sammy? What'd you get? 5x plus 6. Exactly. Because I actually wrote it this way. What property am I using as I'm writing this? Distributive property. Very good. You guys remember? So, of course, by this time you all know that, why, you all understand why we could add 2x and 3x, right? Get 5x. But I showed it to you. Could I add 5x and 6y together?
No.
No, you can't. Why not?
Because they're not the same variable.
Yeah, they're not like terms. And again, could we use distributive property for 5x and 6y to add them together? No, there isn't any common factor, right? The reason why we could do 2x plus 2 plus 3 times x is because there was a common factor of x, right? That's how we could use a distributive property. You guys remember this?
Yeah.
If you know how to do this, like I said, you could add and subtract radicals. So because instead of x and y, guess what we're going to have?
Number.
Radicals.
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 Does that make sense? So instead of x and y, we're going to have radicals. That's the only difference. Okay. So if you know how to do this, you could do the rest of it. Okay, here we go. Let me give an example. So take a look at example 1. It says 8 rad 11 plus 2 rad 11. Instead of x, what do we have, guys?
Rad 11.
Rad 11. Do you know how to add these together?
Yeah.
Go ahead, everybody try. I'll wait. All right, Michael, what did you get?
I got
10
10 rad 11.
rad 11. How many people agree with Michael? Very good. I even wrote the distributive step. Do you have to write that step, distributive property?
No.
No, you don't have to. But it's kind of nice to understand why, okay? So, yeah, you don't have to write that, but I did. All right, do you get the idea? This is as if you have you could think of this as like 8x plus 2x, right? You see how we get 10x? All right, let's move on to the next one. Example 2, we now have 7 rad 3 plus 2 rad 2 minus 3 rad 2 minus rad 3. But you could think of this rad 3 as what? Like x and rad 2 as y. You see how you have different sort of variable? Even you could just think of it that way. Go ahead, everybody try. You should be all able to simplify this. I'll wait. Okay, is it okay if I rearrange them this way? 7 rad 3 minus rad 3, right? Plus 2 rad 2 minus 3 rad 2. Is that okay? Right, so there is really invisible 1 here. So what do we get here? Paige, when we add them together, what do we get?
You get 6 rad 3 minus 1.
Yeah, 6 rad 3 minus. So I actually did the distributive property. And yes, I get 6 rad 3 minus rad 2, or 1 rad 2. How many people got 6 rad 3 minus 1 rad 2? Very good. Could I add them together or subtract them together? No, they're not like them. There isn't any common factor. You can't use distributive property here, right, to simplify. Does this make sense? You get the idea? Okay, let's see how they get a little bit more creative here. Let's look at example 3. Okay, take a look at example 3. I have 25 rad 2 plus 2 rad 27 minus 3 rad 98. Tajwar, do I have any like term?
No.
Yeah, could I add them together now?
No.
No, so we're done, right?
You can simplify it.
Okay, good. Always,
Simplify.
what can we do with square root of 27 and square root of 98? Yeah, you could simplify those. So you gotta do a factor tree, okay? Before you do anything, right, even though it looks like there isn't any common radical, it looks like you can't really do much, but if you simplify, you will see you could simplify this further, okay? So please, always simplify. Go ahead, everybody try. I'll wait. All right, who can tell me what to write? How about Angel?
25 rad 2
Yeah, 25 rad 2, you can't really do much, right? Okay, 25 rad 2.
plus 6 rad 3.
6 rad 3, yeah, because 27 you get 3 times 3 times 3. So you get 2 times 3 rad 3, so we get 26 rad 3, then minus 21 rad 2, right? Because you get 2 times 7, 7, right? Does that make sense? Okay, any question? Okay, so when you simplify this, what do we get? How about Claire? I actually changed it to addition here. So. But what do I get? What can we do?
Wait, this top one or the bottom?
Well, if you simplify this top one, don't you get 25 rad 2 plus 6 rad 3 plus negative 21 rad 2?
Yeah.
Just like Angel said. So what do we do next? Can we do anything with this?
Then you add 25 rad 2 and negative 21 rad 2.
That's right. What do we get when we do that?
I think you get like 4 rad 2,
Mm-hmm. Plus?
6 rad 3.
Good. How many people got 4 rad 2 plus 6 rad 3 as the answer? Any question? Do you see how they got kind of creative, right? So they give you something that looks like you can't really add them together, but once you simplify, right, you know that you can. Okay. Any question? Could we add these two terms together? No, you can't, right? They're not like terms. Okay, so here we go. Let's move on to the next one then. Here we go. Example 4. I've got square root of 432 minus square root of 300 plus square root of 192. It looks like you can't really do much, but do you think you could do them? Yeah, I think you can simplify these. Okay, go ahead. Everybody try. I'll wait. Okay, what's the hardest part on this problem, guys? Really? Okay, how about... Okay, so what's hard? Chuck, what do you think the hardest part on this problem is? Yeah, you have to do the factor tree for each of these, right? So, 432. You know what goes into 432, guys? Well, it's even, so I just started with 216. Now, 216 is also even, so you get 2. So, if you do the whole factor tree, how many 2's do you get? You get 4 of them. How many 3's?
3.
You get 3's. For 300, this is not bad. For 300, you get 2 2's, 2 5's, and 1 3. For 192, this one you get many 2's. You get, how many 2's do you get? 6, and then what?
1 3.
1 3. Very good. So I just wrote it this way. Who could tell me what you get when you simplify these? How about Carly? What does the first term become when you simplify?
12 rad 3 minus 10 rad 3 plus 8 rad 3.
That's what I got too. How many people got 12 rad 3 minus 10 rad 3 plus 8 rad 3? Very good. Okay, that's the hardest part. Of course, once you've done this, it's easy. So what's the answer then? How about, what did you get? Brandon, what did you get as your answer? 10 rad 3. How many people agree with Brandon? Yeah, the whole thing just simply becomes 10 rad 3 because you get 12 rad 3 minus 10 rad 3 plus 8 rad 3. Yes? Easy? Okay, let's do one last one here. Here we go. Okay, here's one last one. Here's the last example. 2 times rad 7 over 2. Now this time they have fractions as a radicand, right? So we still know how to do this, don't we? Plus 4 rad 7 over 8 minus 1 over 2 rad 98. Okay. Remember one of those rules. Could we have square roots on the denominator?
No.
Okay, so go ahead. Everybody finish this up. I'll wait. All right, so we have to simplify each of these terms. First of all, well, the first fraction, 2 rad 7 over 2, isn't that same as 2 times rad 7 over rad 2? Okay, plus 4 rad 7 over, where did I get 2 rad 2? Chuck?
Because it was rad 4, rad 2. Or it was rad 8.
Yeah, rad 8, which is same as here. You know, you get 2 times 2 times 2. Do you see how we got 2 rad 2? The other one, I got 7 square root of 7 squared times rad 2 because 98 is 2 times 7 times 7. Correct?
Yeah.
Any questions so far?
No.
Okay, so what can I do with, so I don't, do I like square roots on the denominators?
No.
What am I going to multiply the first fraction by?
Rad 2.
Over?
Rad 2.
Good. What about the second fraction?
Rad 2.
Over? Okay. Does that make sense? So when I do this, okay, somebody tell me what I get. How about, Mimi, what does the first fraction become when you do this? What are we doing, by the way? What is this called? Rationalizing the denominator. Okay, Mimi, what do I get when I multiply rad 2 over rad 2?
2.
Rad.
2 rad. 2.
No. Okay, so let's just look at the numerator. 2 times, what's rad 7 times rad 2?
With what?
What's rad 7 times rad 2?
14.
Yeah, so don't you get 2 rad 14 over 2?
Yeah.
Okay, what about the other one, Mimi? 4 times 7 rad 4 times rad 7 times rad 2. What do you get?
4 rad
14 over 2.
Is it 2? You got 2 times rad 2 times rad 2.
Oh, there's wait,
What's rad 2 times rad 2?
rad 4.
Yeah, which is?
2,
Yeah, so what's 2 times 2?
4.
So don't you get 4 in the denominator? 2 times 2?
Yeah.
Okay, what about the last one? Well, the last one is the same thing. Are you okay with this?
Yeah.
Do you know how to multiply this?
Yeah.
Okay. Okay, so, by the way, what is 2? Rad 14 over 2. Does 2 go into 2? How many times? So what does that become simply?
Rad 14.
Yeah. What about the other one?
Rad 14.
It becomes rad 14 because 2 times 2 is 4, right? You get 4 over 4, which is 1. 1 times rad 14 is rad 14. The other one stays the same. Now, what is 1 rad 14 plus 1 rad 14?
2 rad.
Good. Okay.
Hey, I still got a
Now, but should I leave it this way, or do I need to make it into a common denominator and then add them together?
Common denominator?
Yeah, I need a common denominator and add them together. So who can tell me how to do this? Song? What do I need to multiply? 2 rad 14 over 1 so that they have a common denominator? 2 over? 2 over what? I need a common denominator of 2, don't I? So what do I need to multiply this first fraction so that it has a 2 over 2? Can I just multiply by 2? No, that doesn't make any sense, right? To a fraction, you got to multiply 2 over 2, which is simply 1. So when, because we want to write it as a 1 fraction. So when you do, don't we get 4 rad 14 over 2 minus 7 rad 2 over 2? Now we could write them as 1 fraction. You get 4 rad 14 minus 7 rad 2 all over 2. How many people got this? Raise your hand. And not all of you. But do you see how the answer is 4 rad 14 minus 7 rad 2 over 2?
Yes.
Can you do something like this for your homework?
Yes.
Good.